The Building Roman Britain project aims to explore the early Roman building construction industry through an analysis of key building materials including stone and ceramic building material, or CBM for short.
The project's been very much a partnership, working between Fishbourne Roman Palace Museum, the Roman Baths and Bournemouth University, Department of Archaeology, Anthropology and Forensic Sciences.
What we hope to learn from the project is where the stone used on the site comes from, where the ceramic building materials come from.
We're trying to work out how that can help us understand better Roman society and how access to these crucial resources was controlled.
So if you can understand the means of production, where things are being produced, how they're being produced, how they're being transported around the country, and that gives you a really good insight into the economy of that time and also how those ideas were being disseminated.
This project is designed to deliver new ways of learning about the past, and the gain for that will be knowledge that we can tell our visitors about, that we can tell the wider archaeological community about, so that they will have a better understanding in the story of Roman Britain.
We've been analysing the material using a portable X-ray fluorescence analyser, or PXRF for short, which essentially is a small instrument that's a miniaturised version of a much larger tool. Irradiates the sample, filling it with energy, which energises the individual atoms within the stone or the CBM. As those atoms de-energise, they give off a characteristic wavelength that tells us the elemental composition of that artefact, and we can use that composition to essentially fingerprint the stone and the CBM.
And this is able to give us quite high resolution data that previously would have been incredibly expensive.
Before, you may have had to have been a bit more invasive by, say, chipping a piece of stone off and taking it back to a lab. Now with this portable technology, you can do it in situ.
Allowing us to analyse many samples across many sites gives a huge data set that we can analyse statistically to try to look at trends and patterns within the data, which we can then use to draw archaeological conclusions.
There have been many archaeological studies of the different materials from Roman Britain. Very often certain materials get overlooked. The stone and the ceramic building material don't always get the attention they deserve. Now that we have these new techniques and these new analyses, it's a real opportunity to look at this material, understand it, because it made such a huge impact on the landscape in the early years of the Roman occupation.
Since the beginning of the Building Roman Britain project, I've spent many days down here in the York Street store analysing a lot of this stone you can see behind me. In addition, we've analysed the building material in some of the other stores here in Bath, alongside some of those pieces that are on display.
The stone itself, we think, almost certainly came from the local quarries, and that's been well known for some time.
Field work has been done investigating quarries in the vicinity that we suspect may possibly have had a connection to this site.
We're here at Browns Folly, which is one of a number of potential quarrying sites that we've been exploring as part of the Building Roman Britain project. And there is an example here of a very nicely preserved Lewis hole, which look very similar to those that we see on the stones in Bath itself. This tells us that Browns Folly could be the site that the Roman baths were procuring some of their stone. Therefore, we've carried out a significant amount of analysis in this quarry, looking at variation in the chemistry between beds and between different outcrops.
What we are doing is looking very closely at the texture of the stone, looking at what the stone is composed of.
What we want to do is be a little bit more detailed about how we examine this material and see if we can work out from the various beds of limestone that are in these quarries to see if we can do a fingerprint, but really between the chemical composition of the stone here with the stone that's up in the quarries themselves.
The Roman stone on the outside is quite polluted, is contaminated. We will be drilling small samples from the stones in the Roman bath area and analysing those for their chemistry. So we've got fresh surfaces from the quarries in the countryside and the stone in the Roman baths, and we can then compare.
That will give us that direct link and for the first time be able to say scientifically that the stone has actually come from quarry X or quarry Y.
CBM stands for ceramic building material, which is essentially all of the bricks, tiles, everything made from ceramic within a building that can be broadly characterised as part of its structure.
Fishbourne's involvement in the project has been mainly focusing on the ceramic building material.
The palace used a huge amount of material. There were tiles used for flooring, there were other tiles used for the heating systems.
Fishbourne Roman Palace was absolutely colossal. In the standards of the time, it probably would have been 50 times bigger than any man-made structure you ever would have seen in your life. It had on its roof thousands of tiles. We've often assumed that they were made in Dalkeith, a site about a mile, 2 miles away from here. But we've never known for sure. And the brilliant thing about this project is it's our first chance to address that question and hopefully to answer it.
One of the advantages of working with the experts here at Fishbourne is they had already identified a potential CBM production site nearby at Dalkeith.
This particular site right here around me that was excavated in 2007, what they found here was really quite interesting to us and to our project. It was a tile kiln 5 metres by 5 metres in size with a stokehole just to the south. What they were producing here were large amounts of brick and tile, and almost certainly it was being used somewhere in this vicinity.
There's significant evidence of clay actually weathering out of the banks down there today. And we were able to actually analyse some of that material alongside our work here. While macroscopically some of the inclusions were slightly different, slightly unexpected, the chemistry of the material seemed to suggest that it was very similar, so it does show great potential as a possible site or a possible source of some of the material here at Fishbourne. In terms of studying CBM, Fishbourne really presents an excellent opportunity because there is a real abundance of material here, not only in its complete form, but there's a range of fragmentary samples of CBM, which means we can analyse many sample numbers of each type. Each one of these is a very different form and would have required very different skills to produce. And as well, their functions are very, very different. So there would have likely been different craftspeople involved in the production of each of these. So we really wanted to know if that was represented in the chemistry of these artefacts. We analysed them first, and they seem to be almost indistinguishable from each other as a data set. So it seems to suggest that these pipes were being produced from the same types of material as the other tiles here at Fishbourne.
That's interesting. We'd always assumed that these water pipes had been made elsewhere and shipped onto the site as sort of complete fired units, ships some distance, whereas the roof tiles we always thought would have been made much more locally. Well, from what you're telling me, we're going to have to go away and start to rethink what we'd originally thought.
What the project's achieved so far is that it's allowed us to test the technique and see that it works.
We actually are getting results back which show that this analysis will provide some very detailed data sets. It's showing already that there's variability between the results that we're getting from Fishbourne and from what we're getting from the Roman baths.
It's pointed up that there can be issues with later modern contamination. When we come to take the project forward, we can adapt it slightly to take that into account.
study has helped us at the Roman Baths because we've made links with the University at Bournemouth. We've also made links with another Roman site, Fishbourne Roman Palace.
Collaboration is always a good thing. It brings together resources, skills and knowledge into one place. The total is very much greater than the sum of the parts.
The study has given us information that we can use in school sessions along the science, technology, engineering and maths agenda. We will be able to use the outputs of this study.
It's given us really an opportunity to not only do good research and actually gather good data, but to present that data in a way that's accessible to the general public.
We're developing a new investigation zone where young people can go and study the site in great detail. 2019, when that centre opens, this will be one of the resources that we can draw on.
There are, of course, though, numerous questions left unanswered.
This is very early days, so we need to collaborate to make this take off. What we can do is, with the analyses that we're getting, to run that by all sorts of experts who are here, geologists, statisticians, other fellow archaeologists, and have a discussion really about what our results might mean.
What we want to do next is to carry out some more PXRF analysis.
So what we need to do is broaden it out, to start looking at a range of other sites, still from early Roman Britain, but to try to see if there's some other differences here which maybe we're not getting just from these two sites.
So there's real potential, I think, for taking this type of almost using archaeological questions to frame scientific analysis in a way that really gives us positive results, rather than looking for the science to simply tell us what happened, asking very interesting questions and using the science to facilitate those answers.